Electric car. Nowadays, everybody have smartphones. Batteries are powering small computer which is running all sort of applications. Now imagine that you have 4 wheels attached to a bigger battery pack which runs an electric motor. This is a very simple presentation of an electric vehicle. Now let's dive into it. Electric vehicle takes power from electric grid and it goes through an electric charger into the battery. Such vehicles can be charged on many different sockets, even the one at home. This means that every household is essentially a charging station for an electric vehicle. We will begin with a power storage unit, battery pack. The idea is that the central core of the electric vehicle must somehow store power. It can be in various forms, but it is still a stored power. Chemical batteries are currently the most common, but there are other technologies that might one day replace them. From power storage, power flows to the controller. This works as a pipeline or a gateway to an electric motor, which will propel the vehicle. The controller does several things. It keeps power even and the same, and it controls how much power will be used. In most cases, it also works as a converter. This means it will convert power from one form to another. This is, for an example, from alternate current to direct current, or it may increase or decrease amperage. Now we move to the electric motor, which takes power from the converter, uses it and converts it into physical power of movement. Electric motors have only one gear because it can produce all varieties of torque and can go from 0 to really high rotations per minute in only one gear. That is why all the electric cars have no transmission and are all automatic. After you get the underlying idea of an electric car, you must realize that all the components are interchangeable and can vary. You must know that hydrogen fuel cell car is still an electric car that uses hydrogen cells instead of battery and transforms hydrogen into water and electric power, which then runs an electric motor. Also, the electric motor can vary and there can be more than one electric motor in the car. For example, Tesla 4-wheel drive Model S has 2 electric motors, one for each wheel axle. Another option is an electric motor in each wheel. Regardless of everything, you must know that basic technology is the same in every electric vehicle you look at. Pros of electric cars are: they don't produce any emissions because they have no exhaust. It is true that they need power, but producing electric energy is much more cleaner than producing and combusting of gasoline. Energy is much cheaper than fuel for internal combustion engines. They require less maintenance. There are very few rotating parts, there is no need for oil, and they have no transmission of differentials. Electric vehicles do not use energy when they are not moving, if we compare this to internal combustion engine vehicles whose motor idles when not moving. Electric motors last much longer than internal combustion ones because there are few moving and bouncing parts. Battery technologies are improving and current ones may not last as long as electric motor is. Battery range is still a bit problematic if we compare this to internal combustion cars. Test your knowledge. Sketch a basic drawing of an electric vehicle with important parts that make it move. What is not a controller's job? A. It keeps electric power even all the time. B. It converts electric power from AC to DC and vice versa. C. It controls how much electricity will be used. D. It works as an electric starter for the vehicle. E. It works as a transmission for an electric motor. What is true for an electric motor? A. It has many rotating parts. B. It consumes a lot of oil. C. It produces a lot of exhaust emissions. D. It is very easy for maintenance. E. It takes time to produce desirable amount of torque. What is the alternative to a battery pack in electric car?